Hello and welcome to this new video. We will discuss today vector addition. Now you all know that vectors have both magnitude and the direction. So obviously it cannot be added by ordinary algebra. Let us take an example, okay, by which we will try to understand how can we add two or more vectors. Let us take an example. Say for example I have a vector. Say this is a vector, a vector, which is in this direction, and let me say another vector. Say I have another vector, say b over here, b vector, and I have to add a with b. Now remember, while I add a with b, that is a vector with a b vector, then always the addition of that will be another vector. Now that another vector will be called as your resultant vector, and we will represent that with the help of a letter, say capital R and the vector. So addition of a and b will give you R vector. It means R vector will be equal to your a vector plus your b vector, say for example. So how can we show it diagrammatically? So remember always, now here we have the vector a. Once again, this is a vector. I'm just drawing the similar vector over here, remember, and then this b vector. Let me draw the b vector somewhat in this manner. B vector, remember, this is the tail of the vector a, this is the head of the vector a. Now from the head, the another vector b has started, and this is the head of the b vector. Here these two vector a and b are in the same order. Remember, if this is the scenario, if this is the condition, then we say that a vector and b vector are in the same order, correct? So tail, head, and then tail, and then once again the head. Okay, so a b is in the same order. Now the addition of a and b, which are in same order, this addition will be the R vector, which will be taken in the opposite order. Now here I have given the arrow, so this one will be called as your resultant vector R equal to a plus b, because I have added a with b. If I take another condition, okay, similarly this type of condition only we will take, but we will try to find out not a plus b, but we will try to find out over here R vector equal to say b vector plus the a vector. Let us find out this, and what will be the diagram, or how will be the diagram look like. Now over here you can say that, suppose for example, same, once again I have given you a vector, I have given you this, and I also have given you this b vector. Similar condition, this and this I have given you. Once again I want to find out b plus a. Remember, under this condition we need to modify this diagram, and we have to write down R vector equal to b vector plus a vector. Likewise, what we have seen over here, that we have found out a vector and b vector, correct? So R vector will be a vector plus b vector. This third side of this particular triangle is giving you a vector plus b vector. Similarly over here we need to find out b vector and a vector, b vector plus the a vector, correct? So how the diagram will look like? So if I can draw a vector here, this is my a vector, say for example this is a vector, this one I have drawn it over here. Then how we will draw the b vector? Remember, a vector and b vector should be in the same order, the one I already told you over here, head and tail. Okay, just remember the head and tail method. So over here also b vector, a vector should be in the same order. Then how the vector will look like? If this is your a vector, then I must draw this b vector. Just think that I'm just taking this b vector and putting it over here. So this one will be my b vector. So that's my b vector over here. So I'm not changing anything with the directions, I'm just keeping it over here, just this a vector over here. That's it. Now the third side will be the opposite order. So the opposite order will be going in this direction. So here this one R vector will be equal to b vector plus the a vector, because it is b then a, correct? Started from b, goes tail, head, then again tail of a, and then the head of your a. And similarly over here it is taken R vector, which is the resultant of b and a, taken, this is the tail and that's the head, correct? So R vector equal to your b vector plus the a vector. Remember here A vector plus the B vector is equal to your B vector plus the A vector. It means A plus B vector is equal to B plus A vector. So this property of addition of two vectors are called commutative. So vector additions are commutative. Please do remember, vector additions are commutative in nature. Correct? All right, let us take some complicated case. This is only one and two vectors I have taken, either A, B, here also A, B. Correct? If it is more than two vectors, then let us take an example over here. Say this is a vector, say B vector. Correct? Let me take that's my another vector, say A vector, for example, and say there is a small vector, that's a C vector, and there is another vector. Let me draw it in such a way, say that's my another vector, which is a D vector. How can I add A vector, B vector, C vector, and D vector and get the resultant R vector? So I want R vector is equal to A vector plus B vector plus C vector plus finally the D vector. Correct? So for this we will redraw this particular picture. So let us redraw this particular picture over here now. Let us draw it in such a manner. So for example, say my A vector, I'm taking this A vector, which is my A vector down over here, that's my A vector. Absolutely. Then I have a B vector. Have you seen a B vector? This is the B vector, this is my B vector. So let me draw B vector. Just I'm taking this one and then putting it over here. So say the B vector goes along this direction. I'm keeping the length of the arrow same. It means I'm keeping the magnitude of the vector same. So in my diagram it may not be same, but more or less it looks same. Okay, so that's my B vector. So I got A vector and the B vector. Now remember, I have once again followed the rule of head and tail. So this is the head of the A vector and that is the tail of the B vector. So this A vector and B vector are in the same order. Correct? So if I want to find out the resultant of A and B only right now, currently, okay, A and B, A plus B, then there I have to draw a third side. Right? We'll be doing it in due course of time. Let me draw. All right, C vector. How do we draw the C vector? Now C vector is in this direction. This is the direction of C vector. So let me take it and put it over here. So let me say that's my C vector. Fine. So A vector, B vector, and C vector I got. Correct? And then D vector. See, the D vector is going along this direction. So this is the D vector. So D vector probably will move in this direction. Correct or not? So D vector will probably move along this direction. So that's my D vector. Correct? So finally, let us find out A plus B first. We will not find out A plus B plus C plus D in one shot. We will find out this successively. A plus B, then A plus B will be added with C, then A plus B plus C will be added with D finally. Fine. So how do we do that? So A and B is in the same order. So I'm drawing a dotted line that will be taken in the opposite order. See the arrow I have given over here. So this will be my resultant of A and B. Remember, this is only the resultant of A and B. Correct? I'm yet to find out resultant of C, D together over here. Okay, so let us find out this, or let us write it down as your, say, for example, say this is my resultant, say E vector. So E vector is equal to A vector plus B vector. So we can write down somewhere over here. All right, I'm using this space. So here E vector is basically I'm getting the A vector plus the B vector. Correct? So A, B addition is E vector. Fine. Now, if you look carefully, this E vector and C vector is in the same order. It means tail, head of the E vector. This is the tail of the C vector and head of the C vector. Correct? So if E vector and C vector are this way, same order, then the resultant will be somewhat here. So the resultant will be somewhere here. So this will be the resultant. I'm taking here as an arrow. This line will be the resultant of E vector and the C vector. Let us write this as, say, for example, say it is a F vector. Correct? So we can write it down as F vector is equals to your E vector plus the C vector. Similarly, F vector can be also written as E vector. So E vector is nothing but our A vector plus B vector and C vector as it is over here. So I have simply replaced E into A plus B, which is already known to us, A plus B. Correct? So say, for example, this is 1. Say I'm writing by 1. Okay, that will be much better. All right, now F vector. So F vector is the resultant of E vector, C vector, and finally F vector is basically the resultant of A, B, and C. That is A plus B plus C. Finally, if you see carefully once again, then this F vector, there is the arrow, and then this D vector are in the same order. So if they are in the same order, if these two F vector and D vector are in the same order, then the third side, that will be your this one, will give you the resultant. So final resultant, I'm getting this one. So finally this resultant will be your resultant of F vector, that is the addition, I mean to say F vector and the D vector. So let us write F vector plus the D vector. So R vector is the final resultant, which will be your F vector plus the D vector. Already we know F vector is how much? F vector is A plus B plus C. So it is your A vector plus B vector plus C vector plus this D vector. So finally the resultant of A, B, C, D, this entire vector in a different directions, we found out the resultant A, B, C, D, and in a simple and a very simple way of adding them. All right, so this diagram, we need to probably remodify this diagram, okay, into this, and then finally we find out F plus B. That's all for today. Okay, we will see in the next video how can we add vector analytically. Correct? So wait for the next video. Thank you.